Welcome to the channel, and today we are going to discuss about thermodynamics. And this thermodynamics we are going to basically discuss about compressors. What are compressors? What is required in a compressor, types, and then we're going to work on a solved problem that you're supposed to encounter in exams while dealing with these problems, your homework or your assignments, etc. I hope you'll get enough from this. Feel free to subscribe to my channel for more informative videos and hit the notification bell so that you won't miss anything that I've posted. We're going to discuss let's move compressors. Thermodynamic cycles. These are machines that take in fluid, usually gas, and delivering it at high pressure than initial pressure. That's basically the definition of a compressor. Types. There are two types of compressors. That is rotary compressors. These are positive displacement compressors. These have high mass flow rate and low pressure ratio, ranging from atmospheric pressure to 9 bars. Reciprocating compressors have low mass flow rate with high pressure ratio, more efficient than rotary compressors. Reciprocating compressors including clearance. Clearance is important to give mechanical freedom. The volumetric clearance of many machines is 6% of the volume swept by the cylinder. And then this is the diagram that I've drawn to show you the volumetric clearance. This is the volume swept. This is the volume swept in meters cubed, and this is the graph. This represents the pressure in atmospheric pressure. This is volume per meters cubed, and this is the TS diagram, and this is the initial. VS is for the volume swept. This is the clearance volume. And then induced volume is VA minus VD, which is VA minus VD. That is the induced volume as shown. Then I'm going to work on at piston C. At point C, piston is descending, creating a partial volume up to point D, where pressure is slightly lower than atmospheric pressure, necessitating the inlet valve to open, and air is induced in the cylinder up to point A. Piston now pressurizes the air up to point B under pressure P2 and temperature 2. The delivery valves open and air delivered under constant pressure. Let's move on to indicated power. Indicated power is gotten by N over N minus 1 MR T2 minus T1, where M is the mass flow rate, R is the constant, which is always 287, N is the compressional index. We're going to find we're going to work out on the formula of getting the volumetric efficiency, which is VC. Volumetric efficiency. Volumetric efficiency is gotten by VA minus VD, which is volume induced over volume swept. We are supposed to express the terms VA minus VD in terms of VC and VS. That is PC VC is equals to PD VD raised to power N. To express the terms VD in terms of VC, this is what, after evaluating, this is what you get. but VA is equals to VS, volume swept plus clearance volume. After evaluating all the equations, you get that volumetric efficiency is equals to VS plus VC plus VC PC PD over 1 raised power n is equal over Vs. After substituting, take note that you should substitute here very well to get this equation, for this is what you're going to use to get the volumetric efficiency. Note that Vc is only used when the condition inside the cylinder are same. This includes temperature, volume and pressure. Worked example. A single stage double acting compressor has free air delivery of 14 meters cubed per minute measured at 1.03 bars and 15 degrees. The pressure and temperature at 32 degrees and 7 bars. The expansion and compression index is 1.3. Calculate the indicated power. The clearance volume is 5% of the swept volume. This is one of the questions that you'll get in your exams as you go on revising. So it's important to write this so that you may not confuse. This is atmospheric pressure, which is 1.01 bar, T1 which is 288 K after converting it to Kelvin, T cylinder which is 295 K, P cylinder is 0.95 bars, P2 is 7 bars. The compression index is 1.3. Note that mass flow rate, we use conditions outside the cylinder. So P1 V1 is equals to MRT1, which is 1.03 times 14 times 10 raised power 5 is equals to M times 287. Note that I told you the R is always constant, which is 287. Get that M is equals to 17 point. After evaluating all these, get that M is equals to 17.16 kg per minute. When finding T2, we use condition inside the cylinder, not outside the cylinder. So that is T2 over T1 is equals to P2 over P1 n minus 1 over n, which is 7 over 0.95 raised to power 0.3 over 1.3 times the temperature inside the cylinder, which is 273 plus 32. We get that is 483.57 K. Indicated power. The formula for getting indicated power is N over N minus 1 times MR T2 minus T1. After evaluating, you get that 1.3 over 0.3 times 17.16 over 60. Note that it's over 60 because the SI unit of time is seconds, and this was 17.16 kg